Yeah, so hello everyone. Good evening. Trust we are having a great day. Can anyone hear me?
Good evening. We can hear you.
All right, great. Mr. Nelson, good evening. I don't know
Good
if
evening.
anyone else can hear me. Can you hear me? All right, great. So let's wait for like 5 minutes. We need to get other people to join and then we can commence. Is that fine?
That is fine.
All right, so it's 1 minute. I'll just do an introduction so we can all start. I'll do an introduction. So yeah, good evening everyone. I hope you had a great day, a great Sunday, and I also want to wish you a happy new year. Right, I think this is our first time of having a session this year, so I think it's safe to say happy new year, right? So thank you for joining today's session, and we are really excited to have you guys here. My name is Daniel Mabadije, and I would be your moderator for today's session. And this year, we decided to kick off with a series on microservices. If you can remember, if you have been on the community for a while, you see that we've had some conversations or various conversations on microservices, everyone with their own opinion on what microservices is, why, when, how should you use microservices? Is it really important to use microservices or learn microservices? Is it, something that it is required for someone that is starting up or someone that, is has a team of just 4 people or 3 people, right? So we decide that we have to, clear the air and get someone who is much more experienced in that field to, do that for us. And we are excited to have Mr. Nelson Ekpenyong join us, you know, on this particular series. This class is not just something that's going to start today and end today. Today is actually the first session of the series, right? So mind you that this is just basically an introductory class on microservices itself. And as we go further, we'll look deeper into it and actually now see the answer for ourselves whether we need microservices and in what context do we need microservices. So once again, thank you for joining tonight's session. We're really excited to have you, and we hope that at the end of this session, you've learned something. Mr. Nelson, over to you.
Hi, good evening. My name is Nelson. As Daniel has already shared, I've been a software engineer. A brief introduction about myself. I've been writing code for close to 7 years now. I've built applications for different industries, fintech industry, e-commerce industry. What else? Education, right? I've built application for government. I've built application for foreign universities. Currently, I write 5 languages. Java. My day job is with Java, and then PHP, Laravel, and then Node.js, and then um, Golang. Officially, right? So I'm excited to be in this class. I can see some people that I recognize here. Of course, Daniel. I've seen a lot more people. So today, I don't know. I feel like I should turn on my camera. Yes, I think
Yeah, that's
so.
fine. That's fine. That's fine.
All right. Good evening, everyone. Good evening. So today we are going to be talking about microservices, why we need them, why we should use them, what it is about, and if you can build them. Um, all right. So without further ado, I'll jump straight to the class. Daniel, please confirm how long is this class?
The class will be for an hour for today.
All
We
right.
would actually look to get it for more, but normally our classes are 1 hour.
All right. Okay, that's fine. All right. So here's how we're going to do it. If you have a question, just put it down, and then after we're done, I'll leave the floor open. Does that work? Just type in the comment section if it works. Okay, let's get straight to it. All right, I'm just going to share my screen. All right, please confirm that you can see my screen. Please confirm that you can see my screen.
Yes, we can.
Oh, great. Okay. Um. Okay. Let me make this. Let me turn this into a slideshow. Okay. So, what are microservices? Anyone? Anyone? Just 2 minutes. Anyone? Just one person. Unmute your mic and say. Anyone? What are microservices? Okay, so let's proceed. All right. Microservices is basically an architectural style, right? It's a way to structure your application and build them and deploy them as a suite of single units, right? You instead of having a large application, you break down your application and then build them as independent standalone applications by themselves, right? You have the option to break down a whole application into little parts that can be deployable by themselves. There's a standard definition. I'm just going to read what's here. Um, Microservices is an architectural style that structures an application as a collection of services that are independently deployable and loosely coupled. Now, so all right, on the screen are two diagrams. The first is a monolithic application, and the one to the right is a microservices application. So what you would have in a monolith is everything bundled into one application: the business logic, the business, the data layer, the controllers, the view, the presentation layer, everything in one code base. That is what makes it a monolith, right? It's a monolith because everything is in one place. Now we are trying to get in a monolith, in a microservices architecture, we're trying to get from the diagram on the left to the diagram on the right, right? Where you have the whole application broken down into independent applications in themselves, right? So the diagram on the right, you have, so let's say you have an e-commerce application, for instance, right? In an e-commerce application, you'd have, payments, you have orders, you'd have recommendation service, you'd have different services, right? So instead of building all that in one place, the microservice architecture says, you know what, let us separate all these modules and build them as standalone applications that we can deploy, right? Okay, do we understand so far? I need to be able to proceed. Do you understand?
Yes, yes.
Great.
Yes,
Just
we do.
great.
Yes.
Okay.
Go.
Now, so let's proceed. Why is microservices important? Why is microservices important? We're just going to go through a few of the points, right? Microservices architecture is decentralized, meaning that each individual service operates independently and communicates with each other through APIs. So let's take a hypothetical microservice application. So let's call it Jumia, right? So let's have 3 services for simplicity. So let's have the order service, let's have the product service, we're going to have like the payment service, right? Each of these services, they don't know about themselves. Remember, they are independent on themselves, right? They are built, as standalone applications. And as standalone applications, they have their own databases. Sometimes they can share, 2 parallel services can share a database. Other times, each service would have its own database. Now, because they don't know about themselves, they have to find some way to talk to themselves. And they only do that using internal HTTP calls. Each microservice is self-contained. It's a self-contained unit with its own database and business logic. The product service has its product database. It has the logic that is specific to products. Adding products, it has logic that's specific to deleting products. updating products, receiving products from a supplier, right? The logic is very specific to what that service should do. Now, this independence allows teams to, of course, develop, deploy, and scale services independent of each other. So, in a hypothetical Jumia service with 3 services, we have the product service, the product service, checkout service, and let's say inventory service, right? 3. Now, because they are self-contained, you can deploy them individually. And here's why, here's where the appeal of microservices coming. Because they are single standalone services, they can be deployed and scaled as the need arises. So let's say, our Jumia service, our Jumia microservice application. We know as a company that when it gets to Black Friday, that orders, we get a lot of orders, right? What that means is that the order service, from our history, from business history, we know that the order service receives a lot of traffic when it gets to Black Friday, right? So because the order service is independent, it has its own business logic, it has its own database, we can then scale just the order service and get ready for Black Friday, right? That's where the appeal of microservices come from. Of course, later on we're going to talk about what the types of scaling and how to scale individual services. All right. Of course, we have spoken about this. Microservices enable horizontal scaling by allowing you to scale individual services based on demand, right? Of course, every time so let's go back to our previous example. Who can tell me what other service in preparation for Black Friday, for instance, what other service would have that amount of load? Anyone? We had identified the product service. The product service has a parallel service, right, that would also expect that amount of load. Anyone?
I'd say the order service. I don't know.
Yeah, that's correct. Anyone? The other service, payment service. Moshood, Rafael, payment service. Great. So those 3 services, right? So now remember that we are preparing for Black Friday. If the order service is going to get traffic, if the order service is going to get traffic, instantly we know that the payment service would also expect traffic, right? That makes us scale just those 3 services independently. Now I had let me quickly read what I had here on the note. The primary difference between horizontal scaling and vertical scaling is that horizontal scaling involves adding more machines or nodes to a system, while vertical scaling involves adding more power, CPU, RAM, storage to an existing system. So let me explain. Now, why understanding scaling is important is because the providers that have the infrastructure for scaling charge a lot of money. And in the context of distributed system, we have to understand how to scale and what type of scaling will work for us. Now, first of all, let's even define, what does scale mean? We hear, oh, it's not scalable. The way you're building it won't be scale. You can't scale. What does it even mean? Anyone? What does it mean for something to scale?
For it to grow.
For it to grow. Great. Any other person? Anyone else?
I think
What does it, if you say something has to scale, what does it mean? Withstand traffic in front of the great. Any other person?
yeah, I think it's just basically accommodating more users.
Accommodate more users. Great. So those are the now the in order of priority, users is first, then withstand traffic and ability to grow, right? Ability to grow is a parallel point to accommodate users. Now, when you say you want something to scale, you are saying that you want that system to be able to handle a lot of load as a result of the number of people that we expect. Does that make sense? Does that make sense? Does that make sense? Right. So, so I'm going to quickly explain what horizontal and vertical scaling means. Okay, so let's say you have a rack in your house, right? Let's say you have a rack in your house, and you are hosting your website in your house. Back in the day, people used to do that. You buy a CPU, you know that you have light always, you host I hope we know that we can host our web applications in the house if we have power, right? A server is just a machine sitting somewhere. So let's say you are hosting your website in the house and you expect traffic. There are two things you can do, right? You can either go to Alaba or somewhere, go to Computer Village and buy another CPU and add to what you have, right? Right? Or you go back to the market and upgrade the capacity of what you already have. Now, so if you go to the market and buy more CPUs, you are horizontally scaling. So you're adding more nodes, to that system. But if you simply go to the market and, let's say, upgrade the RAM from 32 to maybe 100 gig RAM, and then the SSD from, let's say you had give me SSD, let's say one terabyte. You went to the market and bought, let's say, a 10 terabyte SSD. What you have done is vertical scaling, right? So one is adding more nodes to the system, right? Another one is adding more power to an existing system. Does that work? Is that clear? Is that clear? Good. Now, so since each microservice is a separate entity, right, you can scale them, of course, based on demand. If a particular functionality experiences high demand, only that service needs to be scaled, right? Now, this targeted scaling is not only more efficient, but also cost-effective, making microservices a preferred choice for businesses experiencing variable loads. Variable loads means that on a regular day, our Jumia service, we won't have, regular months, we won't have traffic, right? But as it begins to approach Black Friday or Christmas or Valentine's Day or any of those holidays, we would have traffic. So our load is not constant, right? Our load is variable. Now, why this is important is because the businesses that own cloud infrastructures charge a lot of money for projects, and we have to understand what it means to scale and how to scale. So let's proceed. This is another catch, because microservices use different, different services are built independently, right? It allows you to change the stack of a service, right? And by changing the stack of the service, you can bring in different people. So let's go back to our hypothetical e-commerce service. So as part of the service, remember we would have a recommendation service, right? A recommendation service that learns from the buying pattern of a user and recommends other things based on what the person has been buying, right? Now, because it is more recommendation based, we can decide tomorrow and say, you know what, that recommendation service, we want to build it with Python so that we can leverage machine learning, artificial intelligence, and things like that, right? So you see, and what that means is that that team is different, right? That recommendation service will have its own product team. It will have its, it will have its own CTO if you want. It will have its own set of non-technical group. So each service allows you to build and design infrastructure tailored to what that service does, specifically to what that service does, right? So in one service, you can have a Python stack. You can have people writing Java in the same company. You can have people writing PHP, right? The Java people will most likely use Java and Spring Boot to write the payment service because it's more secure, right? The recommendation service will have the people writing Python with Flask or Django because it's more secure, because it has to do, because they have to interact with AI libraries, right? The other service would have people with maybe Laravel, PHP, because it helps them do things faster, right? So as a business, we can look at what each service is doing and staff engineers based on what that service requires. I hope this is a lot. Of course, each microservice is self-contained. It has its own database, right? It allows people to work independently. We have spoken about this, right? Now, microservices encourage a DevOps culture, right? Promoting continuous integration and continuous development. This will lead to faster development cycle and quicker response to business changes. Now, with microservices, you can do without continuous integration and continuous development. It just will not work. It will not work. I am currently on the team for a company, in one team that is building just one service. You cannot operate without a very solid CI/CD culture. It won't work. Now, please, guys, I hope you know that the core of microservices is not so much the business logic, it's configuration. This subject is really wide. It's so deep. So it's not even about what you are doing in each of the services, not about the code, what it's doing. No, it's about configuration, the environment the services will run, how each service will talk to themselves, the authentication and authorization. In our hypothetical Gmail service, by the time we are thinking about authentication and authorization, you realize that not all services cannot talk to themselves randomly. So let me explain. Okay, let me even ask, in this microservice application, how many services can and should talk to the payment service? Unmute your mic. How many services should talk to the payment service? Order, Joshua, you're correct. Order. Who else?
Probably the processing service. That's the word.
Processing. What do you mean?
Like people that would handle out, confirm like the orders and send it out. So they check if that payment was confirmed.
Okay, if you have a confirmation service, yes, that will talk to the payment service. Well, it's one I'm looking for. CAT. Good. CAT service. So in the delivery, good delivery. Now, in the whole system, right? The system that has these different services. By the time we are talking about authentication and authorization, you realize that each service has to implement its own authorization and authentication. So you can't have like a, it's not a one size fits all, like in a monolith where you have, your login and your logout and things like that. No, each service would have its own rules. The payment service will say, no, the recommendation service cannot talk to me. Like, first of all, it won't recognize any request from the recommendation service, right? So imagine a system that has all these services talking to themselves, right? Sitting in different environments. How do you think deployment will work? Manually or automatically?
Automatically.
Automatically. It's a lot of madness, guys. Yesterday afternoon, I wrote a microservices application, just a simple application just for this class. I'm going to show you. I can tell you for free. I can tell you for free. This is not something you want to do on a whim. At the end of the class, we'll talk about, what cases, right? Under what circumstances should you consider either starting a fresh microservices application or migrating the monolith that you currently have into a microservices application. All right, so let's proceed. A microservices application would have, out of the box, because of the way it is structured, it has single responsibility. Each service is doing one thing. Now, remember, single responsibility is from this principle. How can I forget? Single responsibility.
Solid.
Single responsibility is from solid, right? Each where a controller or a method or a service should do only one thing and one thing only, right? The CAT service is just doing things that are related to CAT. So remember, we're going through some of the things that make microservices appealing. Loose coupling, we've talked about the services are loosely coupled, meaning that changes to one service do not affect the other. We are developers, we know this. If you're working in a team, right? We hired someone in the team, and the person decided to be a hero, went and changed this is something that happened 2 weeks ago, went and changed the UUID of man, I don't know if I should say this. Went and changed the UUID. It was bad. Changed the UUID of a table, changed it from what it was. So we used UUID, right? A string, and I changed it and changed it to an object. See, things failed. Now the bad thing is that all the tests passed, right? All our unit and integration tests passed, but it went into production and failed. It was a disaster. So loose coupling, you only appreciate loose coupling when you have been in a team like this, where someone does something and then it affects the other thing. But with microservices, because each services are independent of themselves, you will never have this kind of problem. If something happens with the service, the team responsible for that service will get in and check what the problem is, fix it, and redeploy. All right, let's move. Microservices are fault tolerant. In a microservice architecture, if one service fails, the other continues to function normally. This isolated failure can be dealt with without impacting overall application performance. Therefore, microservices contribute significantly to the stability and resilience of an application, right? Remember, in our Juma service, for instance, if something goes wrong, the application is stable, right? Only that part has a problem. Now, in most cases, with what happens at my place of work, this is a subject of distributed computing. a critical component of designing microservices, guys, is understanding caching at the different levels of caching. Every service, there are 3 levels of caching. There's device level caching, right? If there are mobile developers here, you understand this, where you cache data in the device, right, or the web application. So there's that level of caching. Now there is caching with databases, right? Redis or Memcache or something like that. Now there is caching where you are taking the whole data of the application of the company and putting it somewhere in maybe in Asia or China or whatever, and updating it every week or every 2 weeks. So if a service goes down, chances are that the API gateway, we'll talk about that later on, will begin to call that service, and if it doesn't get a response, it would, first of all, it will go to the cache. If the information is there, it will send it to the user. If the information has changed, before it will try to reach the DB. If that service is down, it will go back to the cache. That way, if something goes wrong, we have our application live. Independent security. Security is crucial. It's a crucial consideration in microservices. Each service was implemented. We've talked about this, right? We've talked about the fact that each service, there's no one size fits all for authentication and authorization, because each service has to implement its own authorization. All right, now we're going to let's look at the different design patterns of microservices. They are basically 5. Google. All right, okay. There's the API gateway pattern. There's the database per service pattern. There's the circuit breaker pattern. There's the event-driven pattern, and there's the saga pattern. All right. So this is the API gateway. Now the interesting thing about the API gateway pattern is that the API gateway pattern merges 2 patterns together. Each service has its own database. The catalog has its own database. What is that? The shopping cart has its own database. The discount has its own database. The ordering service has its own database. All of this sit behind an API gateway. Now, what is the role of an API gateway? Let's quickly discuss that. What does an API gateway do? In a microservices architecture, each service possesses a set of fine-grained APIs. Managing these APIs individually can be a daunting task, especially when the application consists of course, if you have different services, all these services will have their endpoints. So the catalog service will have maybe 15, the cart service will have another 15, discount service 15, ordering 15. In total, that is what, 60 different endpoints. So the API gateway serves as a single gatekeeper that has record of all the gateways and is able to redirect user requests based on what the user is trying to do. It routes requests to the appropriate service and subsequently aggregates the responses. It also handles cross-cutting concerns like authentication, monitoring, and rate limiting. So I'm going to explain this. So you want to, a client wants a request. The API gateway examines the request and knows what service to call. Let's say it needs to call 3 services. It would call these 3 services, aggregate the response as one, and return to the client. The API gateway also handles authentication. It handles monitoring. It handles rate limiting. Who knows what rate limiting is? Rate limiting.
Number of requests that the API will process.
Great. Rate limiting is simply controlling the number of requests that an endpoint can take at any time window. Now, rate limiting IP, good. Now, rate limiting is a critical concern for cybersecurity. I like that you introduce an IP address. So if you have, okay, let's go back to our service. If you have requests coming to the other service, let's say everybody wants to buy something at the same time, what do you think happens to your service? If you simply allow all the requests to hit the service at once, what do you think will happen?
There will be a server
Yes, you
issue.
can have access.
Crash.
Denial of service. Okay. It may not crash. Remember, you are a great engineer. You know, you belong in a team that has an architect, so that must have been dealt with. But it can slow down things. But if there's a way for us to rate limit the calls such that it won't stop it, but it would only send those sets of requests to the service after another batch has gotten responses. I don't know if this makes sense. Does this make sense? Rate
Yes,
limiting does not stop the request. It just it holds it down and says, guys, are you guys done? Something else is coming. And the service will say, okay, give me some minutes, right? And return the response, and then it sends it, so it receives it. That's what it does. Now, the API gateway is the single entry point that does this for us. All right, let's go to the other pattern. The other pattern, database per service. Of course, we've already seen this with the API gateway. Each service has its own database. Okay, circuit breaker. This is my favorite. All right. Services would most likely rely on each other. If a service fails or becomes slow, it can impact all the dependent services, leading to cascading failure. In another 10 minutes or so, I'll quickly show the application we have built. With the circuit breaker pattern, you can prevent a network or service failure from cascading to other services. When a failure is detected, the circuit breaker trips and prevents further calls to the failing service. It then periodically attempts to call the service, and if it's successful, it closes the circuit and lets the call go through. So back to our microservice, back to our hypothetical e-commerce service. So let's say we have three. Someone is trying to make a call to the other service, and somehow the service is down. With this pattern, if it tries that service once, tries it again, and does not get a response, it would shut it down. It will shut down calls to it. Basically, it will tell the other guys, man, that guy is not available. Give me some time. It will periodically make calls to it. Remember, it has requests. It's not just making calls. It has requests that are pending. After 2 minutes, after 3 minutes, after 5 minutes, if it receives a response, it will close that. It will close that channel. Right? Here is the reverse. If it is open, it means that something is bad. Something is wrong. If it's closed, it means that this is successful. Open just means that, it's not closed, it's not open. But every 5 minutes or so, I'm trying to make calls to it. Let's go event-driven, where a service. So this is an architecture where every service has a subscriber. Every service that does something is a publisher, and then another service subscribes to that service, subscribes to that message. So if an event happens, it broadcasts that message through a network, and then the consumer will receive that message and do something based on it. I'm going to share the slides. Let's move forward. We have so much to cover. Saga pattern. Okay, so I'm going to share the slides so that we can go through it. Okay, so let's demonstrate concepts in Laravel. You guys are going to love this. All right. I'm trying to move. Give me a minute. All right. Okay, guys. Yesterday afternoon, I started building this just to demonstrate, just to do a demo for this class. Some things are not very complete. This is just a hello world microservice. You know, as we progress, it's going to get more and more technical. So, all right. So this is a hypothetical e-commerce service. Sorry, guys. Should we do this demo? Should we do this demo?
Yeah, sure.
Yeah, yeah.
Let's get like yeses from a few more people. Should we do the demo? Should we do the demo?
Yes.
You guys are gonna love this. Yes, yes, yes. All right. Okay. So remember that hypothetical e-commerce service I talked about. So let's have it here. But before we do this, right? Let's go to the let us go and see the diagram. Of course, what we have now is the database service. We have a product service, we have an inventory service, we have a checkout service, and each of these services have their own database. MySQL. I had attempted to use MongoDB, but I couldn't install the driver. So I wanted one of the services to have MongoDB, but maybe in the next class I'll be able to do that. Okay. Each of these services. Now remember that services talk to themselves internally using API calls, right? Through a communication, through a protocol, either HTTP, TCP, or any of them, right? Depending on your application needs, right? Here we are just doing internal HTTP calls. So let's go through the order of communication. The inventory service calls the product service first, then the product service returns a response, and the inventory service creates an inventory. The second thing that happens is that the checkout service calls the product service to check if a product exists. And then the third thing that happens is that the checkout service also calls the inventory service to get the product quantity. Don't worry, we are going to go through this in right now. All right. Okay. So this is our microservices application. So we start first with the payment service. Now, I went ahead. Let me just show you guys. So the payment service is already running. The payment service is running on port 8,000. Please confirm that you can see that the payment service is running on port 8,000. Don't know if you guys can see.
Yes.
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 All right.
Yes.
Confirm that you can see that the inventory service is running on 802. Inventory service 802. Great. Confirm that you can see that the checkout service is running on 803. 803. Great. Okay. So we have product, inventory, checkout. All right. So should I go through the code first before we do the calls, or should do the calls and then we go through the code? Code first.
I think code first will be better.
Code first. Great. Oh wait. Let me get the quorum from the code first, or we test the APIs. Code first or APIs? Code first, APIs. I'm looking at the chat room. Calls first, okay? Calls first. Code first. That's how I know. Chat room. I want to understand the. I want to say code first. Code first. Few more code calls. Code. Okay. The codes have it. All right. Let's go through the code. So code is this. All right. So I have a simple application. The code has, let me go straight to the models. Your application starts with your model. This is a poor example. Your application starts with the model. The first thing you want to do, right, before you start any project, after understanding the scope, is to begin to do database design. Okay, that was for somebody. Your application rises and falls on your model, where we product service. Where is the product service? All right. Okay. So the product service has the name, description, price. Nothing fancy. Name, description, price, which is the model. I didn't want to go into the whole fillable thing. I'll first of all talk about the how I design my applications. There's the controller, there's the API controller, there's the service, I have an interface that the service implements the interface, and then I have a repository. I have a repository because I write Java Spring Boot, so I sort of brought the idea to Laravel. Okay, so let's start. This is the service. The product service just has the create a product, get a product, get products, get one product, get a product by its price, find out if a product exists, given an ID. This is the service.
Sorry, is there a way you can increase the cost?
Yes, I just figured that. Sorry, I'm so sorry. Let me do that right away. Please let me know once it is legible. Once it is legible, let me know.
This is okay.
Legible?
Yeah,
Great.
it's fine.
Now, I just have the create, get all products, get a product by its price, find out if a product exists. Now, I have the service that implements, I don't know if I had done this. Oh, okay. Well, this should have implemented it, but that's fine. So what I'm doing here, let me take this down. Repository, and open the controller. Good. So we are doing product now. So first product repository. Now, why the repository pattern is important is because you don't want the service to have anything with calls, right? All database related activity is assigned to the repository. It's a design pattern that helps your code become modular and helps it when it comes to testing. So here I'm saving. This is a save method that just says receives the product and saves it. Find by ID, gets the product, finds or fails. This is from Laravel. Find the price, select price where the ID you give the price to return the price, the specific price. Remember, so if you pay attention, every method has a return type, right? And then if you're writing Laravel, you're writing PHP, please, I beg you in the name of God, type your Laravel. Ensure that Laravel, your code is statically typed. Okay, exists by ID, find all. In the service, you're creating a product. First of all, I'm injecting using dependency injection using the constructor. This is from PHP 8. This is important from PHP. The new PHP, you don't need to do private data here. You can put everything here in parentheses and it will work. Here I am creating the product, just the name, the description, and the price. I'm sending it to the product repository. Remember, I've injected it here, right? I'm simply saying this repository save of that, getting the product, this repository find all. Basically, I am calling the find all here, right? Where's it? Find all. I'm calling the find all, this guy, right? Where else? Where are we? Get products as I do. Let me fold them. Get product by ID. I'm calling repository find by ID. Pass the ID here, right? And then get product price. I'm saying this product repository find price. Remember, all those methods are here in the repository. So remember, so what is happening is that the service is talking to the repository and the controller is talking to the service. Let me say it again. In production environments, in large companies, this is how code is structured. The controller talks to the service talks to the controller talks to the service talks to the repository talks to the database. The DB brings back the data to the repository sends the data back to the service sends the data back to the controller. Does this make sense? Don't worry, I'm going to put this code on GitHub. That's all. Then exists by ID. So let's go to the product controller. Nothing fancy. Okay. This is a bit too big. All right. Again, how the controller talks to the service is by injection. So I'm injecting the service into the controller. Remember, the controller talks to the service talks to the repository talks to the database. So anyone who wants to talk to anybody has to first inject the person they want to interact with. Does that make sense? I hope that is clear. So I'm injecting the service in the controller. This is standard stuff. Then the controller then calls the service to get the product. I'm saying this product service get product. Then I'm returning a JSON response. If I want to call all products, this product service get products. Now this is it. So that controller is calling all the methods, calling the methods here, right? And then that is all. Okay. Products calling the get products in the service. Add products is calling the create in the product service on line 30. Does product exist is calling the exist by ID in the product service. Product price is trying to get the price, right? Look at it here. Get product price. This is the service. Get product price. This is it. Right? Get product price is calling find price in the repository. So remember, service controller talks to the service talks to the repository talks to the database, to the DB. All right. So let's get to the calls now. Calls. Can we do calls now? Calls, anyone? Calls. Okay. I didn't get a response. Okay, let's do calls. Yes, I got at least 2 responses. So great. All right. So now one of the things you want to do, of course, the idea of collections should not be new. When you're working with every project, create a collection and create directories in the collection so that you want to organize yourself. Right? You want to organize yourself so that it's easy for you in future and easy in case other people want to join your product. So this is all products. So let's call this. I hope the database is running. All right. So we have. Please confirm that you can see products. We have the product that are already here. Right. Great. So I already did this in the class. Let's get a product by its ID. Okay, HP MV ID. Let's find 3. All right, 5. Okay, QLED, Samsung QLED. Please confirm that you can see that you can get a product. All right, so let us add a product. Anybody, the first person to give me a product is what we're going to use. Anybody? Let's add one product. Come on.
G-Wagon.
Jesus Christ. Okay. Mercedes. Wow. I thought you were amazing. Okay. I love the G, actually. It used to be one of my favorite cars. So this is G65 is oh, okay. G65 Mercedes Galanda, well, G wagon. Okay, what's the price, sir? Don't tell me, please. That's about 32 million. Okay, I don't want you to tell me the price. I beg you. Okay, that's 320 million. That's for second hand, by the way. That 320 is 320 second hand. That's just on the side, okay? All right. So, okay. All right. So let's add this price. Okay. Let's add this product. You ready? So ideally, numeric value of range, out of range, for range of column price. Bro, you're okay. You know what? Let's do this. Remember, so we've not done validation, we've not done any of those things. We just, so we'll sort that out later on. Great. So we have our G-Wagon product added. All right. Please confirm that we've been able to add a Mercedes G-Wagon, and it has an ID of 7, right? So let's add one more. Any other person, one more, just one more before we go. Quick. We gotta
Samsung Tab
go.
9.
Say again.
Samsung Galaxy Tab 9.
Good. Samsung Galaxy Tab 9. All right. Okay. How much is our Galaxy? How much is our Galaxy? Okay. All right. Good. So we have 7 and 8. Great. So let's find out if the product exists. Okay. Does product exist? Remember that endpoint. Does product exist? Yes, it returns 1. 8 returns 1, right? It's a boolean. Okay. So let's get the product price of 7. This is our G-Wagon, remember? Let's get the product price of 8. Now, why is this important? This is important because all the other services, when they need something from the product service, they are going to call these endpoints. Does that make sense? So let's quickly get to the, let me show you guys the route. Simple, nothing fancy. Product by ID, products, add, exist by ID, get the price of a product. Great. So the product guy is done, right? The product guy is done. So this is the product service. Now let's get to inventory. That the inventory wants to create the product, create an inventory. Now inventory is simply saying this product, how many did the supplier give us? Inventory is just a table, is the service that keeps track of the number of products per product. Great. So before the inventory creates a product, it needs to first of all make a call to the product to say, hey, this product ID, does it even exist? The product service is going to say, give me a minute. It will check and say, oh yes, it exists, and comes back with the response before the inventory service creates an inventory. All right, let's quickly get there. All right. Product service, inventory service. So remember, we have 2 new products, 7 and 8. Remember? Who remembers? Okay. So same thing. Great. Same thing. Because of time, the inventory service. This is the controller. Okay. So here, let's do calls first. Then we can talk about the code. Let's do calls here first. All right, calls first. Where are you? Calls. So you see, I'm closing down the first, let's even find all inventory. Close this. Let's see all the inventories. What do we have? Like everything. Let's see, do we have everything? Oh, great. So we have, please confirm that you can see that the endpoint returns the list of all inventories. Nothing fancy. We get an inventory by ID. But that's not, these are pretty, but here's the thing. Let's go and add an inventory. This is where this is the meat of this class, right? Where each service, so we want to demonstrate how services make internal HTTP calls to other services. Now, what was our product ID? Who remembers?
7 and 8.
7.
We have 7 and 8.
Yes, 7 was the G-Wagon. How many did they supply us? How many G-Wagons did they give us? How many? Who knows?
16.
Jesus Christ. 16 is available is 1. bro, that's like, I don't know, that's like 4 trillion. Okay. Now we're about to add an inventory, right? Before we add this inventory, let's go and find out what is happening in the inventory service. Can we do that? Let's find out what is happening in the inventory service. Sorry, let me close this a bit. Great. Now this is create on line 18. So are we ready? Line 18. Okay, so it will receive the inventory requests. We have a custom request class, right? The first thing that happens is that the inventory service makes a call to the product service to say, does this product ID, the one that the front end is going to supply. Now remember, this is the back end, right? Some UI is going to consume this, right? Now you're going to say this product ID that the front end is giving, does it exist? Now remember, in most cases, your front end will also be a service on its own, right? The front end will also be a service on its own. Will be sitting somewhere in, this product service, does it exist? This is what is happening here. If the response is 1, in other words, if it comes back with a 1, right? If the guy says, yes, it exists, if the product service says it exists, it will say, okay, this inventory, it will go and create the inventory. It will add it to the same. But before it creates it, it will check, does the inventory already exist? Because you can never have inventory for two inventories for the same product, for the same product ID. That is clear. Right? If we said, so they gave us 16 G-Wagons, in the inventory table, we can't have 2 records, 2 rows referencing the same product ID. Does that make sense? That is why. That will most likely be a business requirement, right? So it will first, before it creates that inventory, it will first of all go and check if that inventory already exists. If it does not exist, that is what's happening on line 22. If it does not exist, does inventory already exist? Look at it here, right? Inventory exists by product ID. Remember, this is coming from the repository. Remember, everything is coming from you, or we have a repository, as usual, right? Inventory where the product ID is equal to the ID that you receive. Laravel has an exist function. This method returns Boolean. Yes, it exists, or no, it doesn't exist. Internally, it's just checking if the product exists and returns yes or no, right? So the service is calling this service. This does inventory already exist is calling that repository. So your create will call this method first to find out this inventory, does it exist? If it does not exist, then create the inventory, right? So you see, so let's go and now pay attention to how fast this is. Pay attention to. Can you see? Can you see? Please confirm. Please confirm that you can see that the inventory has been created. Okay. If you yes, great. So you see, the product, the inventory service first makes an internal HTTP call to the product service. Now, see this, to remember this endpoint. Remember the product service was running on port 8000. Remember when we first started the demo? This is the product service 8000 product service. Remember, right? So they are separate, right? They are running separate instances with their databases. So it first of all makes a call to this guy, and depending on the response, it does something. Okay. We're not going to go into all the other things with the inventory service. Where am I? Inventory. Yes. Create an inventory, update inventory quantity. This is going to happen once a payment is made. In the payment service later on, right? Once a payment is confirmed, it would go and subtract that inventory from there. You know what? Let's quickly test this. So product ID was 7, right? Let's say one rich politician came and bought it was 16, came and bought 10, all right? Came and bought 10. So what we left? 16 minus 10,
Yes, 6.
16 minus 10, 6. Great. Now remember, can you see inventory updated successfully? Inventory quantity updated successfully. Now this endpoint can only be called by the payment service. Now remember, this is a business requirement, because the only person that can audit an inventory quantity will be this method in the inventory will be the payment service. So the inventory service will create authentication to ensure that no other person calls it, because if other services can call it, then it will cause problems for our business. All right, let's proceed. Let's go to checkout. Get product quantity. Let's even find out 7, right? We bought 7. 7 was the G wagon. See, it's 10 that is left. Can you see?
Yes.
It's not. So remember, the product ID was 7. So let's even find this endpoint. Inventory quantity 7. Let's find it so that we'll see. This is the inventory service. So you see, on line 29, to get the quantity of a product, all you need to do is pass the product ID and it will give you the quantity that is left, which is what we are doing here, right? Let's see 8. Nobody bought 8. It should still be, what was 8 again? 8 should still be property quantity of no. We don't have a product ID called 8. Was 6. 6 is 10. 7 is 10. Do we have a product ID call of 8? Anyway.
We're supposed to. We created 7 on 8.
Yes, we created 7. We're meant to. Let's do that again. Let's see. Let's do attempt to read property quantity on null. Strange. Okay. I'll debug that. All right. So let's proceed. Let's see. We have 3. We have 4. Product quantity of 4. We have 5. What is left? We have 6. Okay, we have 7. That's the G-Wagon, yeah. 8 was the Samsung Galaxy, I remember. Okay, so let's proceed. Now let's go to checkout. Now you're going to love checkout. You're going to love checkout. We're going to love checkout. This is a checkout service. You will love checkout. Great. Now, when the buyer wants to add to cart, okay, so the buyer wants to add product 7, right? 7 and 8. For 7, how many was left? It was 10, right? They bought 10, 6 was left, so let's buy 3, right? 8, let's buy 2. So this is our cart, right? On the left is the product ID, on the right is the quantity. So this is the JSON, right? This is the JSON that the front end will send to this service. So let's go and look at it. Now, the first thing that I'm doing here is that I'm receiving the request as JSON. That's step 1, right? Step 2, I'm checking if this product IDs and quantity. We are closing now. Hi everyone. Hello everyone. Yeah. Okay. Maybe you want to make an announcement. Go ahead. Oh, great. Okay. So the first thing we're doing here is that I'm checking if the product IDs, if this is empty. If this is empty, it will tell you that the cart is empty. Now the third thing is that I have an array, an empty array. Then I have a result. Now, what is happening in this function? This is a method here. So let's go in and check it. Check if product exists and get the quantity. Now, guys, pay attention. It is your code. Every time you're writing code, ensure that, of course, this is not new. If you have to write a whole sentence just to make the method name, clear, please do it. Because if you come back to the code you wrote 6 months after, it will look like you don't know who wrote it. This has happened to me before. Okay, so let's get to check if product exists and get the quantity. Check if product exists and get quantity. That is exactly what it's doing. It will receive this product IDs and quantity. This guy. Remember, the product IDs are to the left, the quantities are to the right, right? Remember? It will receive it. Guess what it is doing? It will first of all make a call to the product service. Remember this endpoint from inventory where the inventory wanted to find out if the product ID exists. Guess what? The checkout service would also make a call to the product service to find out if the product ID exists. Basically, every time you provide the application with the product ID, it needs to check that the product ID exists, right? It first makes an internal HTTP call to the product service. And if that response is 1, in other words, it says, oh, okay, I have seen that product ID exists. It makes another call to the inventory service to get the quantity of that product. Remember this. Just now when we're trying to test the Samsung Galaxy and it failed. Remember that endpoint. Remember the endpoint that failed for product ID 8. Remember? Anybody remembers? This is the endpoint. This is it. So most likely this will fail because that failed, right? Okay. All right. So now here I am. When I get it, I'll put it in a variable called result. If not, I'll say that the product ID doesn't exist. Then this method calculates so when I get it, I'll calculate the amount of each product in the cart. Now let me quickly say this. The checkout service has its own database. Look at it. The cart has cart items. This cart items simply has the record of the cart and individual items in the cart. Okay, so check if the product, we've seen this before, calculate total amount of a cart. I'll take all the amounts and put it in one. Okay, let's even go and try it. I feel like this thing will fail. I don't know why. I feel like it will fail. Product service. Do we have a product of 8? Yes, we do. We have a product of 8. Inventory service. Inventory service. Do we have a product 8? Oh, we do. Wait, we don't have a product of 8. We didn't add it. We didn't add it to the inventory. That's why we did not add it. So let's go back and add it. Inventory. Add inventory. We didn't add it. Remember, we didn't add it. That's why it failed. They gave us maybe 10. But now we have it. All right, so let's add to cart. Let's add to cart. Great. Cart added successfully. Please confirm that you can see that we've been able to add to cart. Great. So now let's even go and find out if that is true. Because cart, how many carts are active? We have this. Now, what is happening here? What is happening here is that, great, look at it. First of all, no. Carts, check out. Look at this. We have the cart. The cart has one cart of 26, cart ID of 26. The total of value of all the products in that cart, all the items in that cart is 11.6 million. These are the cards. So remember, look at 26. The cart ID is 26, right? The cart items. So you see 26, 26. These are the two things we bought, right? These are the two things we bought. The G-Wagon and the Samsung Galaxy, right? So for the G-Wagon was 7, correct? Remind me, yes, that was 7. And then it was 3. Can you see? So our method calculates the value of each product, each item in the cart, right? And then this is this. This was 2. Once you add this and this, that's what gives you 11.6. So here, cart service, calculate where is that? Calculate total amount of each product. Here it is. Here. So I get the result. Then for each product ID and available quantity, I'm checking if the quantity is greater than or equal to the requested quantity. I'll make a call to the and get the price. You know, this is a loop, right? I have this. I'm adding to cart. I have the product ID. I have the quantity. So here, because I have that, I'm making a call to get the price. This method is making another call to the product service to get the price of each one, right? And then I am calculating that price. So price times quantity. Does that make sense? Does this make sense? I'll share the code on GitHub. Okay, so that is it. Now, okay, as we round up, a few things I need to say. This class is going to be very technically demanding. I'm sure most of you can tell. For the few that are still here, most of you can. It's going to be very, very technically demanding. I encourage you to stick around. If you are able to stick around from beginning to the end, by the time you are done, at the end of this, you'll be able to contribute. You become a much more valuable member of a team. That's 1. 2. You can take on a microservices project and execute it from beginning to the end. Now, let me say this. You will never build full microservices project on your own. And most likely you'll be inside a team that does that. So let us quickly talk about as we close, what circumstances require you to build a microservice. My first advice is do not build a microservice. Let me say it again. My first advice is don't build a microservice. Don't start. Okay? Don't start it. See, guys, let me tell you the truth. I started this yesterday afternoon and I ended just before the class. It was a lot of work, right? It was a lot of work. Internal communication. Remember, we are going to write tests for this as well, right? Now, this payment service, there's nothing there. This payment service will be from Node, right? This payment service will be a Node application that would have a MongoDB. It is a lot of work. Do not start a project as a microservices project. In case you want to, a few things to consider. Do you have the team? What is the skill of the team? Ideally, it should be 3 people to a 3-member team to 4 services. So you have 4 microservices for at least 3 to 4. 3 to 4. That's the ratio. That's 2. 3. Do you have the resources? Do you have the resources to manage a microservices application? If you do not, please do not start a microservices application. 4. Does the organization have the resources to pay for the services that is going to be used for monitoring, logging, authentication. If not, do not start a microservices application. All right. This is where we come to a close. By our next class, we would by then I'll build out these things a lot more. We will have authentication. Would This application would what we currently have now. We would dockerize it and then talk about configuration, right? Microservices configuration. Remember, the meat of microservices is not business logic. It is configuration and communication. Configuration, communication, um, uh, uh, authentication, service discovery, and things like that. It's not merely what you're writing inside. It is how the services are going to talk to themselves. Okay. So thank you so much. We've spent about 26 minutes more. Thank you so much, everyone. This is where I'll draw the curtain for this night. I would share the I'll send this to GitHub. I'll share the code on GitHub, share the repository. I encourage you to clone, fork the repository, follow the account so that you'd be updated, and then so that as I update the project, you also see. I would also make the slides available so that we would follow. Thank you so much. Thank you for your time.
All right, thank you so much, Mr. Nelson. What an insightful session we've had there. So many things to learn. I myself have learned a couple of things. I love the illustration of Jumia that you used over there. It really made a lot of things clearer for us and gave some insight on when to use microservice and all that, and really appreciate you. Thank you all for staying till this time, right? We are like 27 minutes past our usual 1 hour session. So but you can see that it was really an interesting session that we have here. This class won't, be is not going to be finished, right? We're still going to have another one next month, hopefully, because there's still a lot we need to dive deeper. But I'm very sure, or I'm very certain that everyone here, even if you're not a PHP developer, you picked one or two things from this session. So once again, thank you very much for joining this session. Please do well to follow Mr. Nelson Ekpenyong on his social media handles. You could check us on Twitter as well. PHP Talks on Twitter. We've mentioned him there, and we'll also drop a link to his portfolios as well, so that you could do well to follow him. The source code will be made available, and for those who I observed that a lot of people were joining and going out. I believe that will be due to network. So this video or this particular session will actually be uploaded on YouTube. Our previous recordings has always been, from TLDV, but then you observe that sometimes the links get expired. So we have decided that our sessions, when we are done recording and after a review, we'll be moving them to YouTube. So yeah, we want to ensure that nobody misses any session for any reason. So once again, thank you so much for joining tonight's call. I really appreciate, and see you next week. If you are not on the community, please do well to join there as we share updates there as well. Thank you so much. Have a great night, and cheers to a great week ahead.
Bye bye.
Bye.
I've been talking since. Can you guys hear me?